All right, Algebra 2, welcome to Wednesday. Hope yesterday went okay. Today's classwork actually isn't really going to be anything all that new. And I just realized I did not give you much space at all for 3-110, so you might want an extra sheet of paper for this. Has kind of starts out with just kind of reviewing stuff from yesterday, having to subtract pair of algebraic fractions, adding, multiplying, and then also dividing them. So keep in mind, especially for A and D, we do need to get common denominators. So need common denominators. For both A and D here. For B and C, we don't, because keep in mind when we're multiplying fractions, all we do is multiply straight across. With that, you will want to factor this top one. Or not top one, the second one. So in this case, that does become a 15x minus 20 over x minus 5. So we should be able to find that this will multiply. Let's see, the top will factor to x minus 5 times x plus 3. And I'll let you factor the bottom one. Likewise, we want to factor this 15x minus 20 as well. They have a 5 in common, so we pull that out. 3x minus 4. You can probably guess what one of the factors is going to be down here. But we will find with this that things will end up being able to cancel out. Keep in mind as well, dividing fractions, don't forget. Keep the top over x squared minus 4x minus 5. You will want to factor those times, flip the second one. So 2x squared minus 5x minus 7 over x squared minus 7x minus 18. Again, we will want to factor these because pieces will cancel out kind of like they started to here. So for the most part, this one is just going to be review of these last few days. When it talks about exploring with rational functions here, one second, let me make this so it's more visible with the space I have on the camera there. It gives us two functions, 1 over x minus 2, 1 over x plus 1. And it's going to have us look at a few things. First one says, hey, let's multiply these and write them as a single function without parentheses. So it's that idea. It doesn't want me to take, oh, there's my f of x function times there's my g of x function. It doesn't want that. It's not even wanting us to say, oh, this is that, because again, we still have parentheses. We want to actually multiply this all the way through. So we'll end up finding we get x squared, a minus, let's see, x minus 2, x plus 1. If I set up a box, my x squared, a single x, negative 2x minus 2. I'm assuming you can hear the music in the background. Just ignore the dance team. I will shut my door after this for any future videos. If, now that I think about it, there might not be any though. So x squared minus, that becomes just a minus x minus 2. So we have our equation that way. Graph the simplified function from part A. When it's saying that simultaneously graph f of x times g of x, it's wanting us to graph 1 over x squared minus x minus 2 and the 1 over x minus 2 parentheses 1 over x plus 1. Now, keep in mind, when we type this into our calculator, so I'm going to pull out our handy dandy calculator here. When I go into y equals, So my first one, 1 divided by, make sure to put parentheses around your denominator, x squared minus x minus 2. When I do the other one, parentheses, 1 divided by, make sure to do a second set of parentheses for your denominator, x minus 2, close, close. And then again, 1 divided by x plus 1, close, close. Now, when we graph them, hit graph, what we should see is, one, a little bit of a weirder shape than what we saw. And why am I getting an error here? Because I goofed up in this. Second insert. I forgot. Whoops. I just goofed that whole thing up. X plus 1. I forgot that second set of parentheses. So when I tried to close it twice, it didn't like that. But again, we do need to make sure we have a second set of parentheses around the denominator itself. Now when I hit graph, I get my first graph. And in this case, being colored, I can see that the graph is tracing right on top of the other. If you had the black and white calculator, it's asking how can we be sure they're not the same and not one's just hiding out of the window. In this case, because I had a colored graphing calculator, we saw it trace over. But when I hit second graph, I get a table, which I'm at a weird spot, but we can see that both sides are still the same. If I change my table settings so it's back at 0 and just have it count by ones, I see they match again more closely. So, they should be the same. If not, check your algebra, check your inputs if they don't match. Make sure that we add everything in parentheses. So we just did multiplying. It's wanting us to kind of, again, for practice, what happens if we add them, subtract them, divide them, simplify them. And then it says to graph them simultaneously, so that's doing that same thing to check it. Again, they should be matching. So, all right. And then 112 talks about this idea of, do we think that they're closed, rational expressions are closed under addition, subtraction, multiplication, division. So again, what closed means is, so if I look at whole numbers, or just the positive numbers. Positive numbers under addition, I take two positive numbers, I add them, they're going to be a positive. Take two numbers, I multiply them, they're going to be a positive. They're closed under addition and multiplication. But if I subtract two positive numbers, I don't necessarily get a positive. So like if I did 3 minus 7, that gives me a negative number. That would not be closed. What we see is with our rational expressions, so far, multiplication, if I multiply two rational expressions, two fractions, I get another fraction. So I would say, yes, it's closed. The graphs look different than our normal whoosh whoosh, but they are still there. It's still a fraction. We're good. You should find that they are closed for all four of these. But, all right, I'm gonna shut this off since dance team's getting annoying, or their music at least is getting annoying. Thanks, bye.